Hello, wonderful people. We are doing our next lesson, which is 8-4, which is all about the law of cosines. So last time we looked at the law of sines, which is what happens, right, when you have a angle and the side across from the angle is known. Today we're going to look at the law of cosines, which is the other law that allows us to find parts of a triangle if the triangle is not a right triangle. So that's what we're going to look at mainly today. So we're just going to be using the law of cosines over and over and over. Lots of practice today. So the first thing that we have to do is figure out what is the law of cosines, right? So new vocabulary today. We've already done inverse function. We are going to use the inverse functions today as well. And we already know what cosine is. So we're not going to define these two again, but we are going to go to our theorems and postulates page and we're going to look at what is the law of cosines. So let's jump down there and look at it. Okay, so here's the law of cosines. It's a lot of words and it's kind of hard to read, right? But it says the square of one side of the triangle is equal to the sum of the squares of the other two sides minus twice the product of the other two sides in the cosine. And you're just like, what the heck does that mean? Okay, so we're going to write down the three different scenarios for this triangle. Remember that if the triangle is not labeled ABC, it changes, in the equation, but the pattern of it is still the same. So what this means is, let's say if I want to know side A, so A squared right here is equal to the square of the other two sides, so B squared plus C squared, minus, and then we always put this last part in a bracket because it's clumped together and we can't combine them, okay? So it's equal to, minus the product of 2 times A times B, so those other two, sorry, not AB, this is where I'm getting thrown off. Sorry, 2 times B times C. So the other two sides, whatever two sides here are the same two sides that are going here. Okay, times cosine of whatever angles across from the side you're solving for. So notice I only use angle A and side A on the outsides of this equation. Everything on the inside are the other two sides. Okay, so that's if I was solving for angle A or solving for, angle A or solving for side A, I would use this equation. If I wanted to solve for side B or angle B, I would use B squared equals, now the other two sides are A squared and C squared, and it's minus 2 times those other two sides, so 2 times A times C, times the cosine of whatever angle is that you're solving that side for, so it's B. So again, the only time I'm using B's are on the outside. The other two sides are what is inside, right? So inside I have AC, AC, and then I have angle B on the outside and side B on the outside. And then if I was solving for C, it would be the same thing. Side C equal to the other two sides, which is A squared plus B squared. And then minus 2 times those two sides, so 2 times A times B, times cosine of your angle, which would be C. So it's the same equation, right, over and over and over and over again. Just depends on what you're solving for, what angles you're given, things like that. So if you're given angle A and you're solving for side A, you're going to use this top one. If you're given sides A, B, and C and you're trying to solve for angle B, you would use the middle one, right? So it just depends on what you're given in the problem and what you're trying to solve for to determine which angle or which equation we're going to be looking at. So that is the law of sines. We're going to be writing this out quite a bit today. So get ready to have some fun. We're going to go back to 8-4 and we're going to use these equations, or really just the one, right? And modify it as necessary according to whatever it is that we're given in these problems. Okay, so here we are at example 1, when it says use the law of cosines to find a side length. So the question is, what is length BC to the nearest tenth? So here's length BC. That is across from angle A, okay? And so I'm going to label this side A. Now, the question, right, is do I know an angle and a side across from the angle? And the answer is no, right? I know angle A, but I don't know side A. So I can't use law of sines. So that's my clue that I have to use law of cosines. Since I'm given angle A and I'm trying to find side A, I can use my A squared equation equals B squared plus C squared minus 2 times B times C times cosine of angle A. So that's what I'm going to be using. The reason I know I'm using that equation is because I know angle A, so I can put that here. And I'm trying to find side A, so this is what I'm trying to find. So we can just plug in our values. I know side B is 10, and I know side C is 8. So I can just plug in those values, okay? So let's get started on that. So A squared is equal to B squared is 10, so 10 squared plus C squared. C is 8, so 8 squared minus, now I always put these in parentheses, right? 2 times B, which is 10, times C, which is 8, times cosine of angle A, which is 57. Okay, and so that is something that I've just plugged in all the values that I know. I know angle or side B was 10, I know side C was 8, and I know angle A is 57, so I plugged it in. So we're just going to simplify this equation. 10 squared is 100, plus 8 squared is 64, minus 2 times 10 times 80. 2 times 10 is 20. 20 times 8, I said 80, sorry. 20 times 8 is 160 times cosine of 57. Notice I'm keeping this 160 times cosine of 57 together, and that's going to be really important here in a minute. Okay, so A squared equals 100 plus 64 is 164 minus bracket 160 times cosine of 57. Now, this is why it's so important to have this bracket or parenthesis here. I cannot subtract 164 minus 160. I cannot do that. Okay, this 160 is being multiplied by cosine of 57. That would be like saying, what's 164 minus 160x, right? I can't combine those because there's an x here. This 160 is being multiplied by something. Same thing in our law of cosines, this 160 is being multiplied by something, so I can't subtract them. But this is something that I can go ahead and enter into my calculator to help me solve. So let's pull up our calculators. It doesn't have to be a graphing calculator. A scientific calculator will work just fine on this. But let's get out our calculator and I'll show you how to enter this. Okay, so here's my calculator. The first thing is you want to make sure you're in degrees. That's going to be pretty bad if you're not in degrees and if you're in radians instead. So make sure that you've switched your calculator into degrees. And we're just going to enter this whole thing into our calculator very carefully. So we're going to enter 164 minus, now I want to make sure that that 160 and the cosine of 57 is together. So I'm going to open up a parenthesis. You also could open up a bracket, which is above the parenthesis, but a parenthesis is fine. Or there's brackets here too, either way. Okay, but 164 minus 160 times, not sine, excuse me, cosine of 57. Remember that it automatically opens a parenthesis when you hit one of those trig functions. So I have to close the trig function and then also close that first parenthesis that I put in. And I get 76 point, let's just say 86. Okay, so A squared is equal to 76 6.86. But I don't want a squared, I want a, so I have to take the square root of both sides. And when we do this on our calculator, we've talked about this before, but we can use this ANS, this answer button right above the negative. So I'm gonna go square root, and then instead of entering this whole number in because it won't be exact, we'll have rounded it, right? I'm gonna hit second answer. And what that's gonna do is it's gonna take this line without rounding and plug it in. And I hit enter. And it wants me to round to the nearest tenth, and typically for sides, we round to the nearest tenth, sometimes the nearest hundredth. So in this case, it's 8.7668. So we're just going to round this up to 8.8 units. So that gets me that A is approximately 8.8. And since I don't have units on the 8 or the 10, and I'm not given units, we're just going to write units. So A is approximately 8.8 units. If you feel like you're ready to try it, we do have some try it's here. I am going to go through one more before giving you a chance to work, but if you feel like you're ready for it, go ahead and hit pause whenever you're ready and you can try this. Our first one here says, what is the value of DE? So DE is across from angle F, so this would be side F, right? I know angle F, and I know the other two sides, so I'm going to use my law of cosines, which will be F squared is equal to D squared plus E squared minus 2 times D times E times cosine of the angle across from this side, which is angle F. So again, it's the same pattern. I'm just using different variables because of how my triangle is labeled. So we're just going to plug in our values. So F squared is equal to D is 6. So D squared would be 6 squared. Plus E is 8. So 8 squared. Minus 2 times D, which is 6, times E, which is 8, times cosine of angle F, and angle F is 62. And once I have everything plugged in, I'm just going to simplify down. So F squared equals 6 squared is 36, 8 squared is 64, minus 2 times 6 is 12, times 8 is, 96, times cosine of 62. And there we are. And I can combine this 36, excuse me, that looks like does not equals. I can combine the 36 and the 64, which gets me 100. So 100 minus 96 times cosine of 62. And again, I cannot subtract this 100 from the 96. Can't do it. But I can enter this whole thing into my calculator. So if we get our calculator back, I can do 100 minus, I'm going to open a parenthesis, 96 cosine of 62, close it, and hit enter. And I get 54.93-ish. So F squared is equal to 54.93-ish, right? And so then I need to take the square root of both sides. It's the only way to get F by itself without the squared. And again, I'm going to use my answer button. So I'm going to go square root and then second answer. So then I don't have to enter this whole thing in, and I'm not rounding. And I get 7.411. So this rounds to 7.4. So F is approximately 7.4 units. Okay, so we have two try-its here. First one is what is the length of G to H. That is across from J, so we can call that side J. And then the other one is it gives you 3 values, so you're going to plug them in on your triangle and then use law of cosines to solve. So I want you to pause the video. I want you to actually try both of these, and then when you're ready to go over them, go ahead and hit play and we'll review them. Okay, so let's look at what is the length of side J. I know angle J, I know side H, I know side G, right? So I'm going to be using my J squared equals G squared plus H squared minus 2 times G times H times cosine of angle J. Now, if you start to get to the point you don't have to write this out every time, totally fine. But if you notice it's just the same equation over and over and over, we're just changing the variables as the image changes. Okay, so J squared, that's what I'm trying to solve for. G, side G is 18, so 18 squared, plus H is 12, so 12 squared, minus 2 times 18 times 12 times cosine, and angle J is 110. So I've plugged in my values. It's time to start simplifying. 18 squared is 324. 12 squared is 144. Minus 2 times 18 times 20. Sorry. Wow. 2 times, I just got really lost. Okay, 2 times 18 times 12 is 432. I looked at the wrong problem. Times cosine of my angle, which is 110. Okay, 324 plus 144 is 468 minus 432 times cosine of 110. Now, once I have that simplified, this is something I enter into my calculator. So let's get the calculator back. And I have 468 minus 432 times cosine of 110. And I get 615.8-ish, right? So J squared is equal to 615.8. But I want J, so I have to take the square root. So I take the square root of both sides. Let's get our calculator back. So I'm going to take the square root of this answer, and I get 24.8. So J is about 24.8. And again, I don't have units, so I just need to say units. And there it is. If you needed help on that one, and so you haven't tried this one yet, just go ahead and pause the video and try this one. But we are going to go over it now. All right, so here I'm given the angle C is 31. I'm given that angle A is 25. Sorry, side A. And I'm given side B is 29. And I want to know what is C. So I don't know an angle on the side across from it, so I can't use law of sines. But I do know an angle on the other two sides, so I can use law of cosines. And I'm trying to find C. So in this case, I'm going to have C squared is equal to A squared plus B squared minus 2 times A times B times cosine of the angle across from C, which is C. So I'm ready to plug in. Side A is 25. So this will be 25 squared. Side B, right, is across from angle B, and that's 29. So 29 squared minus 2 times 25 times 29 times cosine of my angle, which is 31. and we're going to solve. I'm going to kind of move it over here so that we have some room. So 25 squared is 625. 29 squared is 841. 2 times 25 is 50 times 29 is 1450 times cosine of my angle, which is 31. And so we're just going to simplify. 625 plus 841 is 1466. So I have 1466 minus 1450 times cosine of 31. And now that's something I can enter into my calculator. So 1466 minus 1450 times cosine of 31. I get 223.1-ish. So c squared is equal to 223.1. Right, I'm going to take the square root of both sides. And so I'm just going to use square root answer because I don't like rounding until the very end. And I get 14.936. So you could write 14.9, you could do 15. Either way, I'm going to leave it at 14.9. So C is about 14.9 units. And there is my side. Okay, so again, it's just the one equation over and over and over again. What we're going to look at now is how do I use that same equation, but now how do I find an angle, right? So all of our examples and try it so far have been finding a missing side. Now we're going to look at what if I'm looking for a missing angle. Okay, so here I have a solar panel. It says the optimal tilt for Cosines' solar panel is between 58 and 60 degrees to the horizon. So here's the horizon right here, right? So I want this angle to be somewhere between 58 and 60 degrees. Has Cosines placed his solar panel at an optimal angle? I don't know, right? So I want angle P. So that tells me that at the end, I'm going to have cosine of P at the very end. Well, whatever this angle is, that's what side has to be on the other side of the equal sign. Okay, and then the other two sides, which are Q and R, can just get filled in 2 times Q times R. Right, can just get filled in on the inside of the equation. So that's how I figure out what equation I'm going to use, right? I know that I'm trying to solve for angle P, therefore angle P has to be in the equation. Well, if this is angle P, then on the other side of the equal sign has to be side P. And I know side P, I know side R, and I know side Q. So I can plug in those values and solve for angle P. So that's what we're going to look at here. Okay, so side P is 19. So 19 squared equals side Q is 18. And you could have done the R first. The Q and the R, the order doesn't matter there. Plus R squared, side R is 20. So 20 squared minus 2 times 18 times 20 times cosine of P. And again, I don't know what angle P is. That's what I'm trying to find. Okay, so let's start simplifying. 19 squared is 361. 18 squared is 324. 20 squared is 400 minus 2 times 18 times 20 is 720 times cosine of P. Okay, and I can simplify. 324 plus 400 is 724 minus 720 times cosine of p. Always keeping in mind what I'm solving for. I'm trying to get this cosine of p by itself. Okay, so now here I can't combine 724 and 720 because 720 is being multiplied. So the only thing I can do is move this 724 to the other side. So we can subtract this to both sides. And 361 minus 724 is negative 357. And then what's left, right, these cancel. And I'm left with negative 720 times cosine of p. So don't forget this negative here, right? And I don't need the bracket anymore because I no longer am adding or subtracting anything to it. So I'm just left here. And again, I'm trying to get this cosine of p by itself. So I'm going to divide both sides by negative 720. Okay, so let's go to our calculator. And I have negative 357 divided by negative 720. And I get 0.4983 whatever, right? So 0.4958, 4958. I was like, wait, that's not right. 49583, blah, blah, blah. And that equals cosine of p. Now, this is where we get into our inverse functions. Remember, the only way to get rid of cosine is to take the inverse of both sides, right? So that gives me that the cosine inverse of this 0.49583 ... sorry, my dog just moved, is equal to, and then these guys get to cancel and I get p. So on my graphing calculator, or on my calculator, sorry, it doesn't have to be graphing, here's my number, right? I want to take the cosine inverse of this. So again, I'm going to use that answer button. I'm going to do second cosine inverse, right? So that's above cosine. And then answer key. Close the parenthesis, hit enter. And I get 60.275, so like 60.28 or 60.3. So I get the measure of angle P is about 60.3 degrees. Okay, and that's awesome. We've solved it. But the question is his solar panel at an optimal angle? And the angle we want is between 58 and 60. And the angle is at 60.3. So is it at an optimal angle? No, right? We want it to be below 60 and above 58. So Keenan has not placed the solar panel at an optimal angle. Right? So it's just a little bit too steep. It needs to just go down just slightly here. Okay, if you feel like you're ready for a try it, feel free to pause the video and give these a shot. I am going to go through one more with you guys before I ask that you pause it and try it. But if you feel ready for it, you can go ahead and pause it anytime and give it a shot. Okay, so this one says, what is the measure of angle X? Right there. So since this is what I'm trying to find, that's going to be what's inside my cosine, which means what's on the other side of the cosine is going to be x, side x, right? And then my other two sides, y squared and z squared, are the two sides that fill in. So then that's how I figure out what equation it is I'm going to use. So let's fill in my values. X squared is, x is 4, so 4 squared Then I have y, which is 6, so 6 squared, plus z, which is 7, minus 2 times y, which is 6, times z, which is 7, times cosine of x. And then this is what I'm trying to find. Okay, so we start simplifying. I get 16. 6 squared is 36. 7 squared is 49. Minus 2 times 6 is 12. Times 7 is 84. Times cosine of x. So at this point, we're just simplifying, right? Nothing too crazy. 36 plus 49 is 85. Minus 84 times cosine of x. Remember, I cannot combine that 85 and the 84 because the 84 is multiplying by cosine. So the only thing I can do is subtract 85 to both sides. Okay. 16 minus 85 is negative 69. And what's left is negative 84 times cosine of x. I want that cosine by itself, so I'm going to divide both sides by negative 84. So let's do that on our calculator. If I can get my calculator to pop up. There we go. So negative 69 divided by negative 84. And I have 0.8214, right? So 0.8214-ish, right, equals cosine of angle x. So now I need to take the cosine inverse of both sides. So that tells me that the cosine inverse of 0.8214, all that stuff, is equal to x. So if I go back to my calculator, I'm going to take the cosine inverse of this answer. Okay, and it won't round it or anything. I get 37 or 34.77, so like 34.8. So I get the measure of angle x is about 34.8 degrees. And there it is. Okay, so to try it now, I want you to pause the video. I want you to do both of them. So pause the video, find what is the measure of angle P right here. And then the second one, I want you to fill in the values that you're given and find the measure of angle A. When you're ready to go over it, hit play and we'll look at it. Okay, so let's look. What is the measure of angle P? So again, since angle P is what I'm trying to find, that's going to be inside of my cosine. And then that tells me that side P is on the other side of the equal sign. So that means that side R and side Q are the two that are being used in those other spots. Okay, so let's just plug in values and go. Side P is 13, so I have 13 squared. Side R is 8. You could have done the Q first, it doesn't matter, right? You could have done 11 first and then 8, or 8 first then 11. Side Q is 11. Minus 2 times 8 times 11 times cosine of that angle P, because that is what I'm trying to find. 13 squared is 169. 8 squared is 64. 11 squared is 121. 2 times 8 times 11 is 176 times that cosine of P. So just nice little simplifications here. 169 equals 64 plus 121 is 185 minus 176 times cosine of P. Again, I cannot subtract those two. I cannot subtract 185 and 76, so I just can only subtract 185 to the other side, which leaves me negative 16. So that equals negative 176 times cosine of p. Divide both sides by negative 176. There's not really enough room to write all this, is there? So let's go up here now. So 16, negative 16, let's do it. Negative 16 divided by negative 176. It's 0.090909 repeating, so 0.09 equals cosine of p. Take the inverse of both sides, so that tells me that the cosine inverse of that 0.09 is equal to p. So I'm going to use my calculator, and I'm going to use the answer function on my calculator, so I don't have to round. Oh, I don't know why I did that. Sorry. Negative 16 divided by negative 176. And I'm going to do the answer function, take the cosine inverse of that. There we go, and I get 84.78, which rounds up, so 84.8. So the measure of angle P is approximately 84, not 8.4, 84.8 degrees. So we're just using the same equation over and over and over. The last one that's like this, before we move on to our last example, is very similar. A here, I know side A is 28. I know side B is 30, and I know side C is 32. Okay, and I want to find angle A. So since it's angle A that I want to find, right, I know that my cosine is going to be cosine of angle A, which means that my A squared is going to be on the other side of the equal sign. And then my B squared and C squareds just get to fill in from there. And so I just start plugging things in. Side A is 28, so it's going to be 28 squared equals side B is 30, so 30 squared, plus side C is 32, so 32 squared, minus 2 times 30 times 32 times cosine of that angle A. We start simplifying. 28 squared is 784. 30 squared is 900. 32 squared is 1024, 1024. Minus 2 times 30 times 32, 1920, times cosine of that angle A. Always keeping in mind what it is I'm solving for. So 784 equals 900 plus 1024 is 1924 minus 1920 times cosine of A. I can subtract this 1924. That's the only thing I can do, which gets me negative 1140 equals negative 1920 times cosine of A. We can divide both sides by negative 1920. So let's see what we get there. So negative 1140 divided by negative 1920 is 0.59375, so 0.59375 equals cosine of A. Take the inverse of both sides, so I'm going to take the cosine inverse of 0.59375. And that's going to give me angle A. So the measure of angle A is approximately, let's go back to our calculator, and we're going to take the cosine inverse of this. And it's 53.576, so 53.6. 53.6 degrees. And there we are. So same equation over and over and over again. We're going to do it 2 more times here. Okay. Example 3. These are our last 2 problems. It says the district ranger wants to build a new ranger station at the location of the fire tower, which is right here, because it would be closer to Bald Mountain than the old ranger station. Is the district ranger correct? Okay, so I want to know what is the distance here, right? The old ranger station to Bald Mountain is 2.1 miles. I want to know what is this distance. So we can call it, maybe let's call it R for ranger station. I don't know. So I'm going to be, this is what I'm solving for. So that's going to be what's on the other side of the equal sign. And then my other 2 sides, well, one of those sides is 2.1. The other side is 1.4. And then I'm going to subtract 2 times 2.1 times 1.4 times cosine of the angle across what I'm trying to find, which is 49 degrees. So since I know angle R, I can plug that in. So R squared equals 2.1 squared is 4.41. 1.4 squared is 1.96. Minus 2 times 2.1 times 1.4 is 5.88 times cosine of 49. So let's start simplifying a little bit. 4.41 plus 9.46 is 6.37 minus 5.88 times cosine of my angle, which is 49. Can't actually subtract these two, so the only thing I can do here is plug it into my calculator. So let's do that. 6.37 minus 5.88 times cosine of 49. So 2.512-ish. So R squared equal to 2.512 dot dot dot. But I want the R, not R squared, so let's take the square root. And I get R is about, so let's go back to our calculator. I want to take the square root of this. So I'm going to use second square root. I'm going to use that answer key. And I get 1.585, which, rounds up to 1.6. Let's just say 1.6. So R is 1.6 miles. So this distance right here, we can get rid of the R, is 1.6 miles. So is the ranger right? The old station is 2.1. If we build a new station at the fire tower, it'll only be 1.5. Or 1.6, excuse me. So the district ranger is correct. The district ranger. Remember, whenever it's a word problem, you have to answer in a sentence. Is correct. The fire tower is closer. Okay. Good. So let's look at our last one here to try it. I've already solved for part of this, right? I know that this is 1.6 miles, so I can plug that back in. It says, assume a path is drawn from the fire tower to Bald Mountain. What is the angle the new path forms with the old path? So this is what I'm trying to find right here. We can call it angle B. That's what I'm trying to find. Okay, so I want you to use all of the tools in your tool belts, pause the video, give this a try, see if you can figure it out. And then, and there's actually multiple ways to do it. And when you're ready to go over it, hit play and we'll look at it. Okay, so there's a couple ways that you could do this. You could use law of sines because you know all three of the sides, right? And then you can find angle B. So you could do 1.4 squared equals 2.1 squared plus 1.6 squared minus 2 times 2.1 times 1.6 times cosine of B. So you could do that, and that would get you the right answer. The other thing that you can do is I noticed that I have an angle and the side across from the angle, so I can use law of sines, and I like that better just because it's not as much work. So I can use law of sines and say sine of the angle I know, which is 49, over the side across from that, which is 1.6, equals sine of my angle, which I don't know, angle B, over the side across from that, which is 1.4. So law of sines, right, was last video. And so whenever I have an angle and the side across from the angle, I can use law of sines. So here I would just cross multiply. So 1.4 times sine of 49 equals 1.6 times sine of B. I want that sine of B by itself, so I'm going to divide both sides by 1.6. So I get 1.4 sine of 49 over 1.6, and that equals sine of B. Remember, I don't want sine of B, I want just the B, so I have to take the inverse of both sides. So sine inverse of all of this, 1.4 sine of 49 over 1.6. So, and that whole thing will equal B. And that's something that I can plug into my calculator, right? So let's do this. I'm going to clear it. I have 1.4 sine of 49. Then that is divided by 1.6, right? And then the whole thing, I'm going to take the sine inverse of, and I get 41.3. So the measure of angle B is approximately 41.3 degrees. So the angle created is about, not exactly, but about 41.3 degrees. So again, because it's a word problem, I have to answer the question in a sentence. All right, guys, that is it for law of cosines. Hopefully just that repetitive, doing it over and over and over will help. If you have any questions, make sure that you reach out and ask, and we'll see you soon.